Podcast. Welcome to AI Podcast. I'm David. Today we're turning one of our explainers into something you can listen to on your commute. The topic is a 2022 paper titled Training Language Models to Follow Instructions with Human Feedback. You might know it by its shorthand, RLHF, and the model nickname, InstructGPT.
Hi, I'm Maya. I'll be the curious voice in the room. Could you start with a quick takeaway before we dive in?
Sure, the big idea is simple. If you train a language model not just to predict the next word, but to do what people actually prefer, you get an assistant that follows instructions better and tends to be more helpful and less harmful. The team fine-tuned GPT-3 in 3 stages. First by learning from human written demonstrations, then by learning a reward model from human preferences, and finally by using reinforcement learning to steer the model toward answers people consistently like while keeping it close to the original. The result, InstructGPT, was preferred by human evaluators over the original GPT-3 on real user prompts. It was also generally more truthful and somewhat less toxic, with caveats we'll cover.
That sounds promising. Who led the work?
The paper is by Ouyang and colleagues at OpenAI's alignment group with leadership you may recognize, like Leike and Schulman. The focus throughout was aligning model behavior with human intent.
All right, what problem were they actually solving?
Pre-trained language models are optimized to predict the next token on broad internet text. That objective doesn't guarantee they'll follow instructions. So they can drift off topic, sound confident while being wrong, or mirror toxic patterns from their data. The gap is between raw predictive skill and what users experience as helpful, honest, and harmless. The paper treats that gap as an alignment problem. Change the objective so the model's behavior lines up with human preferences on open-ended, real-world prompts.
Right, because the best next word isn't always the best answer. What had people tried before this?
2 main threads. One is instruction tuning on curated task collections, which helps but doesn't fully reflect messy real prompts. The other is learning from human preferences, where a model learns which outputs people like by comparing pairs of answers. Before this paper, those efforts were narrower in scope. The contribution here was scaling that recipe to the diverse things people ask large models to do day to day.
Walk me through their approach in plain language.
Step 1 is supervised fine-tuning. They gather prompts and ask trained labelers to write high-quality answers. The model learns to imitate those examples, which gives it a baseline bedside manner.
So it learns from good examples first. What comes next?
Step 2 is the reward model. Instead of single answers, labelers compare pairs of responses and pick the one they prefer. A separate model learns to score any candidate answer based on those preferences. Think of it as a learned proxy for what people like.
And the final step?
Step 3 is reinforcement learning. The system generates answers, scores them with that reward model, and updates the policy toward higher scored behavior. They use PPO with a penalty that keeps the new policy close to the original so it doesn't drift. They also test a variant that mixes a bit of the original pre-training objective back in during reinforcement learning to preserve general skills.
You mentioned real user prompts earlier. Where did their data come from?
From 2 places. One stream came from real prompts submitted by API users, filtered for privacy and safety. The other was prompts written by trained labelers to broaden coverage. Using real usage matters because it grounds the model in what people actually ask.
How did they test whether the new model was actually better?
The primary check was practical. Show evaluators answers to held-out real prompts from different models and ask which they prefer. They also measured truthfulness with a benchmark that tempts models to repeat common misconceptions, looked at toxicity using both raters and automated tools, examined bias with established tests, and track performance on standard NLP tasks to see whether alignment came with a cost.
So what happened in the results?
The instruction-aligned models were chosen more often by human evaluators. A much smaller InstructGPT model could beat the original, much larger GPT-3 on everyday prompts. When they compared equally large models, the aligned version was usually preferred. They also saw gains in truthfulness and fewer toxic replies when the system was asked to be respectful. Bias was harder to move, and there was an alignment tax. Focusing on conversational helpfulness could lower some public benchmark scores. Mixing in a bit of the original objective during reinforcement learning recovered much of that.
Alignment tax is a memorable phrase. Can you unpack that?
If you push a model toward being a good conversational assistant, you change its behavior. Some changes help dialogue, but they can nudge it away from the style certain benchmarks expect. Blending in the original objective during training acts like a seatbelt. It reins in the drift and preserves more of the general skills.
I can imagine someone asking whether this just teaches the model to please a small group of raters. What about generalization?
Good question. The authors checked preferences from labelers who weren't part of training, and those evaluators still preferred the aligned models. That suggests some generalization. Even so, the rater pool was small and mostly English-speaking, so cultural and linguistic coverage was limited. The paper is candid about that.
Let's pause on the main limitations without turning this into a rant.
First, the size and diversity of the labeler pool. Dozens of trained contractors can't represent global preferences. Second, cost and coverage. Human preference data is expensive, so many comparisons had only one rater, which reduces redundancy. Third, evaluation distribution. Using real API prompts is great for realism, but naturally favors instruction-tuned models. Finally, reproducibility. The full training and evaluation prompts aren't public, so exact replication is hard outside the organization.
And those improvements in toxicity and truthfulness had some conditions, right?
Yes, reductions in toxic outputs were stronger when the system was asked to be polite or respectful. Preference training shapes how the model responds, but it doesn't erase everything learned during pre-training. Bias remained a challenge on the tests they used.
Before we wrap, what's your intuition for why this works?
Base models are trained on a noisy mixture of goals. RLHF swaps in a clearer goal. Produce answers a person would prefer, given a prompt and an assistant role. The supervised stage teaches a good style. The reward model converts comparisons into a useful signal, and reinforcement learning amplifies behaviors people consistently like while damping the ones they don't. The KL penalty and the mixed objective variant keep the system from over-optimizing the proxy.
And that approach clearly influenced modern chat assistants.
Exactly. The paper showed that changing the training objective can matter more for user experience than simply scaling up model size. That was a turning point.
If someone wants to build on this, where should they focus?
Broaden and diversify feedback across languages and cultures, and aggregate multiple opinions per comparison. Make alignment explicitly multi-objective so helpfulness, honesty, and safety are balanced with transparent trade-offs. Continue reducing the alignment tax with smarter training mixes and data curation. Open up more realistic evaluations so progress can be measured on everyday prompts. And stress test generalization to new domains and non-English settings.
Let me play back a quick summary to check my understanding. The paper by Ouyang and colleagues at OpenAI took GPT-3 and aligned it to human intent in 3 steps. Learn from demonstrations, learn a reward from preferences, then use reinforcement learning to steer the model toward answers people like while staying close to the original. The resulting Instruct GPT models were preferred on real prompts, tended to be more truthful, and produced fewer toxic replies when nudged to be respectful. Bias remained hard to fix, and alignment can lower some benchmark scores unless you counteract that during training. The main limitations are who defines good, the cost and coverage of feedback, and reproducibility. Future work is about broader feedback, clearer trade-offs, better retention of skills, and more open evaluations.
That's exactly it. Calm progress with real gains on what matters to users, and honest open questions left on the table. If you remember one thing, it's that changing the objective can matter more than just making the model bigger.
Thanks for walking us through it.
And thank you for listening. This was AI Podcast. If this helped, share it with a colleague who wants a grounded explanation of RLHF without the hype. Until next time, take care.